Okay, so last time we created a nano game, just game one, and all it does, we'll show it off here. It was in Janet, and all it does is it creates this little window and allows us to use our arrow keys to go over this yellow goal and tell us that we win. And if we press enter, it is done. So that is game one. So game two, we're actually going to essentially keep the exact same output of the game, but we're going to change the internals to make it more reasonable. So that way we can build off of it for later. And so what I'm going to do here is I'm just going to copy game one and we'll just break with our tradition and go game two. So we'll have game two here and we'll start with the same game. So what we want to do is actually create what in normal game engines would be called entities. So we want to be able to bundle pieces of data together. And that allows us to work with the data a lot easier than we would normally. Now in Janet, the way that we bundle pieces of data together is in structs or tables. So in Janet, a struct is an immutable table, and a table is a mutable table. So we're going to use mutable tables, and we can use its idea of object-oriented programming by creating a essentially creating a table that we will use as a template for other tables. So if you're familiar with object-oriented programming, you typically have classes, and classes are essentially templates that you can create objects out of. So Janet has something similar. It actually has what are called prototypes. And so we can create this entity or a table as a prototype, and then when we create we can create a function that will allow us to build these prototypes. In fact, let's make this a little bit larger. And so this is an idea of creating a table that's going to be our prototype. And then down here, the idea of a factory function is that we can create more of these cars by taking the base car prototype that we have and adding it as a prototype to a table that we want to have, right? And so that table may or may not have other things inside of it. So this, in fact, this car will have, like, say, a serial number, which we want to give it as a random one. So we're going to do the same kind of thing with our entity. In fact, we're just going to start with, say, a player, or actually, we're going to actually create an entity and then make a player out of it. So the way that we'll do that is we're going to go up here and we'll say def player, just like we have over here with the car, and we're going to create a table for it. So the table is going to have a player, which is going to have an X value and a Y value. And let's see, I think that's pretty much all that we need for our player. Maybe give it a color. And our player is going to be, our player, I believe, was red before. Draw a rectangle, red, yes. So that's what we're going to do here is we'll create a red color for our player. So that essentially bundles all the information, the current information that we have about our player together. And that gives us a player. So now we can create a function called makePlayer, which will allow us to build a player that we want to have. We could have, actually, we could just have, technically, we could just have X and Y, which will start out. Okay, we'll just keep this, right? The player, we'll give it an X and Y, and we'll have it set that particular thing. And hopefully this will work. We'll try it out, and we'll give it maybe color too. And so then we'll say, like we have over here, we'll have table set proto. So table set proto. Is that how it is? Oh, set proto. There's no thing there. And so we're going to start out with just, say, an empty table. Actually, you know what? We're gonna say X is X, Y is Y, color is color, and we'll start out with this player, right? So this is just to kind of make it follow the pattern that we have. So now we can create a player that we want to have, and we can do this in main. So instead of this x and y, we can actually give it, we can take that away and we can create a player. So def p1, and we'll say make player. We'll have, what was it before? Actually, what did we have before? 50 and 250. So let's do that. So def player. In fact, we want it to be a variable. Player, make player 50, 250, and we're going to give it red. And then we can take away this as what we had before, and we can actually do, let's see, so center x. Okay, so what we can do is we can actually just have a center x plus y, xy. Oh, you know what? We should have a player where the square, we can give it the size. And we'll just have it be a normal, actually, I think we had it as 50. Okay, so that will give us the size, and then we can actually add another thing onto this player. We can actually give it a, we can give it a center x, which will be a function. So that way, instead of having to calculate all this, we will just calculate it every single time for itself. So we'll be able to get the center, which it will take nothing. And then it will return the x plus 25. So it will be, oh, actually, I believe we can have self with this. I believe if we create, yes, we can use self. So essentially, we can put methods on our tables and our structs. And so if we use self, that will allow it to reference its own self. So we're going to do self. Self x and x 25, or actually over plus self size divided by 2. Right, so that allows us to add allows us to get the center of our thing, of our player, and then we can get the center y of our player by doing the same thing with y. Let's see, there we go. So those two methods allow us to get the center. So now we don't have to worry about this center. We've kind of bundled this in. And then, oh, we should also probably have a speed. We can put that in there, which is 5. We can get that away. And then we'll probably also have maybe some kind of, actually, maybe we should just have an entity. We'll create a entity. Because what I'm thinking here is if we create a generic entity, we can create a player off of it. And so what we'll do is the entity will be this table, which will also have an x and a y. And the entity doesn't need to have a speed, but it should have a color. And we'll just give it a maybe a color of white. So there we go, as a default color. And then let's see, is there anything else that we need from it? The entity will probably want to get the center of it. So we can do this. There we go. Okay, so that gives us an entity. And then what we can do is, based off of this, we can actually do a player, which is going to have, we can actually do this with it. Well, it'll have X, Y, a color, and and then we'll give it entity. So that way it kind of inherits all of the X and Y, the center X and Y pieces of it. And we can also give it a speed and size. Speed We'll give it 5. Size, actually size already has, let's do size. Over here, that'll be 50. So that way a player has these things. And so that way we make a player and it's based off of an entity. And then we can make make goal. And we'll give it an X and Y and a color. And we'll do the same thing, table proto. And we'll do X, X, Y, Y, and color, color. There, so now we can make a player and we can make a goal. We'll still use this distance function, and we'll have main. We can create a player and we can create a goal. Var goal, make goal. And the goal is going to be, was it 900 and 250? 250. And the goal will still be the yellow-like color, which I think we have down here, which is goal 0.8.80, right? Okay. 0.8, 0.8, 0. So now we have a goal, and then we don't have to have the goal center anymore. We can have done while not done. So now we've bundled these things together. And now we don't have to set the center anymore because that is just part of our entities. So now let's see if we go, oh, the other thing that we probably want to do with our, when making a player is have it, give it the possibility to do an update for itself. And so maybe what we'll do is by default, maybe our entity will have an update of just a function that does nothing. Okay, but then our player will have an update where it is a function that takes nothing, but it does the update with the keys that we want here, right? So we can do this. We can copy our user output, and we'll have this, and we'll just paste this. And this looks like a little bit of a mess, but let's see, just to make sure that it has proper indentation. Okay. We'll just bring these back. So this is the logic for the key up and down, and that will give us that. And then there we go. So that gives us the entity. Okay, cool, cool, cool. And then what we can do is actually, to make this a little bit more readable, we'll set the prototype of this to be entity. So now it has its own filled in update function. Now the only thing that we have to do here is we can set the self x, right? So self x and self speed. And we'll do the same thing here, self x, self x speed. Same here, self y, self speed, self y, and self speed. So this should give us the proper thing. Oh, we almost missed a couple here. Self y. So this allows us to change where our player is, and it takes all of this logic out of the main loop. So we can say this, and we can say update entities. And since we only have our user, we'll say update was player, right? So one of the things that we can do is putting the typically when you, this is a little Janet thing. So if you want to access something out of a table, like if we want to access the player's X, we typically do this. However, if you do the reverse, it can also call, basically this will say, hey, this is the object. I want to call this and give it self as an argument. And so that allows us to give self as an argument, which is a nice thing to have. So then we'll do a distance, and we'll get center X of player, right? And center Y of player. And we can even do this as saying, okay, we're going to, have more of these things. And we're going to say goal, or actually center X of the goal. And center Y of the goal. There we go. So that gives us a, distance, boom, 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 and that's less than 25. Then we will draw, you win, and then when the key is down is true, that's good for that win. So that allows us to bundle things a little bit better together. And then we'll clear our background. We'll draw the rectangle. Let's see, goal X and goal Y. So we'll say, let's see, goal X and Y. So this will be actually just it's goal, and we're getting the X, and this will be goal, getting the Y. And then this, actually, when we draw it, it will be the size, right? So we can actually put this as goal size. And this can be the goal color. And then when we draw our rectangle, we're going to have, in fact, yeah, okay. But we'll get to this in a second. Okay, we'll have player X, player Y, player size, and this will be player color. Okay, so let's open up a different thing here, and we'll say Janet main, and we'll see, oh, let's see, unknown self. Why would it be unknown self? Where's 22? Oh, self. There we go. Table proto 29 or 29. Okay, table proto. Did I misspell it? What did table set proto? There we go. Okay, so we got a little error, so we can fix that. Target time, arity mismatch. Expected 2 got 1. Okay. In table set proto, main Janet 29. So let's see what we've got here. Table set proto. Oh, yes, obviously. In fact, let's make this look a little bit better. And then when we set the prototype, we will set the prototype for entity. Or there we go. So that should be much better. Okay, so now we've got the same. Okay, good. So the one other thing, so we've essentially bundled things together, and the usefulness of this will be once you have these like entities, you can have loops and you can create them and you can update them and you can draw them. And so one of the things that we probably want to do up here is also have a nice little function for draw. And since we know that these entities are just going to be squares, well, yeah, since we know that they're just going to be squares for now, let's see, we'll do self for update and self. We'll just have the base entity always draw a square, and then we can always replace that with something that will be, better than a square. So what we'll do is we'll take the idea down here of drawing a rectangle, and we'll place it inside of here. So when we draw self, we're actually going to draw a rectangle, and we'll say self x. In fact, we can just do this, replace player with self. There we go. And so then we can take this back over here. All right, so wait. Boo. Oh. Boom. There we go. Much better. So now what we do is we have a draw method inside entity, which means when we make a player, it will have this draw method already in there for both the player and the goal. So we can go down here and we can just say draw player. Actually, did we want to draw? We wanted to draw the goal first. So draw goal and then draw the player. And let's just comment this out for now. If it works, then we can delete that. So let's go back over here, Janet main, and looks like we can draw, and it works. So we can go back over here, delete these two. Now, if you notice, let's go back into game one. This won't always happen, but if you go down here, there's like 51 lines of code, and this is 72, so it's a little bit more lines of code. But certain things are a little more compact. So you notice that our main function here is just really long, while it fits in less than a single frame over here. And so that allows us to have things that are a little bit more readable because we've got these reusable components here, which is kind of nice. And probably the main reason that we've got more is that, like, this entity, we've added a bunch of things to it. But yeah, so that is a working game. So in, I don't know how many minutes, but with a lot of explanation at the beginning, we created, essentially, we reorganized the same game. And this is something that you shouldn't be afraid to do, because reorganizing your internal code can help save you time in the future. And so one of the things that I do, especially for my personal projects, is have a cycle development where I cycle over it over and over again and actually say, is there a better way to do this? Is there a better way to organize the code? And if you can do that, if you do it correctly, it will actually save you time in the long run. So that's it for game 2. Well, I guess, let's see, we had this is game 1, this is game 2. And let's see, yeah, this is game 2. So that's nice. So we've got essentially the same game, and but it's better organized, which means we'll be able to use these kinds of entities, ideas, for our next game. All right, till next time.